Assalamualaikum warahmatullahi wabarakatuh. Hi guys, we'll meet again, right? That's good to see you guys. But before that, let me introduce myself. My name is Wulandestri Lianti. I'm from Raden Fatah State Islamic University, Faculty of Science and Technology, majoring in chemistry. This is about physical chemistry, right? Like before, we're from 18th group, but today, not like before, I'm with my partner. Today I'm alone because the social distancing of COVID-19. I hope our Earth will be better next day. But don't worry guys, if I alone today, cause my partner Gala also have a nice video to you guys. He will prepare a son's video about Waals Equation, so wait for it. I think immediately I will explain about this is the deviation from perfect behavior, so I hope you can enjoy my explanation. Okay, now I'll explain about deviation from the perfect behavior, such as the compressibility vector, Virial Coefficients, and critical constants, and all begin from the compressibility vector. Since the ideal gas law does not accurately represent the behavior of the real gases, we shall now attempt to formulate more realistic equation of state for gases and explore the implications of this equation. These equations, if measurement of pressure, molar volume, and temperature of the gas do not converge, the relation PV equal RT within the precisions of the measurements, the gas is said to deviate from ideality or to exhibit non-ideal behavior. To display the deviation clearly, the ratio of the observed molar volume, this is molar volume, and ideal molar volume times equal RT divide P is plotted as a function of pressure at constant temperature. This ratio is called the compressibility vector, and the compressibility vector is called Z. That's why the equation of the compressibility vector is Z. But in the ideal gas, Z equal is 1. So, because we explain about deviation from the perfect behavior, this is the real gas, not the ideal gas. So, the equation of the compressibility vector Z doesn't equal 1. It means the difference of the ideal gas and the real gas in the deviation from ideal gas behavior is the compressibility vector Z. If the ideal gas have a compressibility vector same with 1, but in the real gas, the compressibility vector Z doesn't equal 1. About the equation of the compressibility vector, we know about the graphics of the compressibility vector. Actually, this is the graphic of the critical constants, but I add it on the compressibility vector to make you understand of the compressibility vector of the gases. This is the compressibility vector, right? This is actually the correlation between the compressibility vector Z and temperature and the pressure. This is PV equal RT. So this graphics of the gases make sure the correlation between the PV and RT. So there's a correlation between pressure and temperature and volume of the gases. So this graphic make graphic of the gases make the critical points of the gases and make the compressibility vector have a correlation between the deviation of the perfect behavior. So it makes the correlation between the gas. Okay, after we know about compressibility vector, we learn about this Virial coefficient. For the Virial coefficient, that's the equation from the Waals equation. This is the Waals equation. So, if the Waals equation will explain by my partner, I'll just call it to you. This is the Waals equations. P plus A divide molar volume decrease times molar volume minus P equal RT. Or if you have moles, pressure plus moles decrease times E divide molar volume decrease point molar volume minus moles times D equal moles R temperature. So for the Virial coefficient, they still have correlation between Waals equations. This is the equation. So for the Virial coefficient, PV equal RT times 1 plus B divide V plus C divide V degrees plus D divide volume degrees 3. So B, C, and D are called the second, third, and fourth of the Virial coefficients. So this is the equation of the Virial coefficient. This is for just general. So pressure times molar volume equal constant gas constants times temperature 0.1 plus B is the seconds of the Virial coefficient divide molar volume plus C, the third of the Virial coefficients divide molar volume decrease points D is the fourth of the Virial coefficient divide molar volume 3 degrees. And for the Virial coefficient, there are digits is the functions of the temperature. So if we have a Virial coefficient, it means that was the function of the temperature. So the Virial coefficient, like before, that was have a correlation between temperature, same with the ideal gas. So for the Virial equation, this have a like the ideal gas, but we not learn about ideal gas, but real gas. Z for the ideal gas, right? We have Z equal 1, but in the real gas, Z doesn't equal 1. But for the equation, it's almost same with the ideal gas, VV equal RT. So for the Virial equation, we just add the B, C, and D. Even more, for the Virial, for the second, third, and the fourth Virial equations. This is the Virial coefficient, the correlation between the ideal gas or the deviation of the perfect behavior. So it means why the Virial coefficients if a correlation between deviation of the perfect behavior. That's why, because whoever this is Virial equation, Virial coefficient. So this doesn't ideal gas but real gas. So that's it. Okay guys, after we know about Virial coefficients, we will learn for the next is critical constants. For the critical constants, I have some data for the gases such as helium, hydrogen, nitrogen, oxygens, carbon dioxide, sulfur dioxide, water, and mercury. This is data for the pressure, volume, and temperature. So for the critical constants, like before, we have graphics, right? This is the critical constants of graphic of the critical constants. So this is for the gases, and here this is the critical points of the gases. So for the critical constants, like I said before, this is the data, and we have equations. Molar volume. We have critical constants equations. Volume of the constants, volumes constants equal 3 RT constants divide 8 pressure constants. So for the critical constants, we have such as data that constants. So like the ideal gas, VV equal RT. This is for volume, constant volume. So in the critical constants, like before in graphic, like right, we have a equation. Actually, this equation that we have in the van der Waals equation. So we have the derivations of the van der Waals equation and make this equation for the critical constants. So for the critical constants equation, we have this is molar constants, molar volume constants equal 3 RT constants divide 8 P constants. V for volume, R for the gas constants 0.082, and T for the temperature constants, and PC for the pressure constants. 3 and 8. This is that we have from the van der Waals equation. So we have so that means for the this is deviation from the perfect behavior have a correlation between the van der Waals equations. It means for the real gas, we will talk about deviation from perfect behavior and the van der Waals equation. So that's the two of the matter have the correlations to each other. That was about the real gases. So if I talking about deviation from the perfect behavior, you can check the next video of my partner Gala. He has saying about talking about the real gases about van der Waals equation. So this is from me for deviation from the perfect behavior. That's it. Okay guys, thanks for watching. Don't forget to like, comment, and subscribe our video and YouTube channel. Also hope you guys can watch my partner video about Waals Equation by Gala. Have a nice day. See you in the next video. Wassalamualaikum warahmatullahi wabarakatuh.